/os.html. Okay, and if that went through with something like that, you're in the position to go there and directly surf your results. Okay, so again, it's pretty old-fashioned, and you're unlikely to find this in many places these days. Anyone know what the big thing that prevents this from happening on most real applications is? Okay, disabled stored procedure, which we'll get to. And also these days, you're unlikely on any serious application to find the web server and SQL server living on the same box. So you probably did write to inetpub www root, but it's not on the box that you're actually facing right now. So you've created your old school page just somewhere else. Okay, so we started to need, as soon as the SQL server and the WW server split apart, we started to need some way to confirm that our commands were actually executing, or to confirm that we were doing something on the target box. In some instances, we found that those boxes could talk clean out, which was a pleasure, but that stopped happening around 2003 or so. Okay, so at that time, what we were going for was you exec your command, and in some way or the other, you get your command to talk back to you. Okay, so you try ping, you try SMB, you try netcat, you try just about anything. And about the same time, what people figured out was that it's relatively reasonable to start using some form of timing also. Okay, so instead of echoing old school is cool, what we could do is simply say, ping yourself 20 times. Okay, and based on the amount of time that that page took to come back, we're in a position to say that we are executing our commands. Okay, now if you combine this with what we just saw with onetime.py, you can start to see where the stuff is going. Something else that was interesting was often you end up using DNS. Okay, so the first command that you execute on the box happens to be nslookup mu.mu.mu.sensepost.com, and then you sit and you watch your DNS log files to see if anyone requests mu.mu.mu.sensepost.com. Okay, and we generally like DNS because at some point DNS makes its way out of your network. Okay, and generally you'll find even on relatively well-hardened networks, even through a DNS chain, something comes all the way out, something makes a request for mu.mu.mu.sensepost.com, and we get to confirm that our stuff's actually executing.
So for a while, when we've been going through these DNS tunnels specifically at SensePost as an example of trying to determine if we've got command execution, there's a whole bunch of tricks that were sort of floating around the office. And I guess it's certainly not unique. What it normally boiled down to was your knowledge of the Windows shell. So what we found was that if you start with some fairly horrendous Windows shell scripting, you can try to initiate commands, so you can execute commands, and based on that, you can try to start deriving the results via DNS. So if I switch to, not there, I want this guy. So what I've got here, basically it's going to run off your screen, but there's a pile of,
Use the green button.
use the
Green button.
Use the green button. Right. This Mac stuff is all new to me. If you've got an injection point that allows you to execute commands, what we can do is we can start to put in little snippets of shell scripting. And so this particular one under DOS or under Windows will execute the command over here, the R and the C drive. And for what it'll do is it'll break it up into tokens, right? So for each token in each line, it will take the first token and it'll initiate an NS lookup of that token appended with sensepost.com appended. So we can take this injection string, flip to the browser, and guess I didn't cut that. Okay. So what I've got here is I'm going to inject this into the browser, but in order to verify if the stuff is actually coming back, I need some place where we're going to monitor these requests. So typically what we would do here is, because we own sensepost.com domain, we also control the name server where those requests for sensepost.com are going to arrive. So what we'd do is log on to our DNS server, start up a TCP dump, and wait for these requests to come back. So what I've got at the back here is TCP dump that's going to be running. I'm going to execute a DR in the C drive, and what we'll hopefully see are each of the first tokens coming back. So submit that. And you can see it starts to take some time. And on this side, we'll see that there's blah.txt, there's boot.ini over here, and so on. And so we can get file names based on this fairly dirty shell script hack. But this method's got a lot of problems. And what we find is that it works for small pieces of data. So for file names, for instance, it's relatively okay. But the problems that we find are it sucks for anything binary. So because this is DNS, what we have to do is look up domains within a certain character set, otherwise NSLOOKUP is just going to barf. So we can only look up ASCII values, we can only look up alphanumeric characters with a couple of punctuation marks thrown in there. So we can't do binary over this. And it also breaks very nicely on spaces. So if there's a space in a file name, or if there's a space in command output, then we lose whatever's after the space because we're tokenizing on spaces. And there's ways around that as well, but in essence, they're all just hacks. And the final point, which is fairly significant, is that that method sucks for anything over 255 characters. So if the output, even if it's a file name, or even if it's output of a command that doesn't contain spaces, it's only alphanumeric, if it's over 255, NSLOOKUP's also going to barf, because DNS domain names just can't be that long. So what we developed was a little tool called Squeezer. Squeezer is a fairly generic tool. One of its channels that it uses is DNS. And so what we've done with Squeezer is added a DNS tunnel to it. It was inspired a little bit by Sec1's Automagic SQL Injector, which I guess if you're doing web application assessments you've used in your time. And it was a very nice tool for what it did, and certainly at the time it was pushing the envelope. And we've taken that idea of sending commands or causing actions to be taken on a server and drawing them out separately into Squeezer, and we've just brought it a couple of years into the future. So what it gives you is a simple shell, like Automagic SQL Injector gave you. It gives you a shell to pull server-side data into tables. Now, when I say pull server-side data, that means anything that's sitting on the server. So that could be data on the file system, that could be command output, that could be data which is actually sitting within the database. And what it also gives you is a return channel to get that data from the SQL server to me, who is the attacker. And those two things are not related at all. And what it also gives us is binary safe transport. So now we don't have to worry about characters that don't fall into the DNS allowed range because we do conversions there. The final point it allows us is a reliable transport mechanism. DNS, by its nature, it's UDP for the most part. It's not reliable, it's best effort, but Squeezer builds reliability on top of that. What do you require if you want to run Squeezer? Ruby. So you don't have to have Python installed. You can remove it if you want. You also need TCP dump. We basically use TCP dump to capture our requests. You need access to a DNS server, generally, dependent on how you're going to run it. And the final point is you need a fairly large SQL injection vulnerability on an application. So when I say large, basically the injection point has to take a string of roughly 600 bytes, dependent on the mode that you're going to use it in. So the basic operation with Squeezer, with the DNS channel, is as follows. We initiate an HTTP request which causes data to be put into a table. Now that could be a command execution, and that's what we'll show. And then we initiate a series of requests after that, which basically go through that table with the output. We break those, for each row in that table, we break it up into blocks. We convert those blocks into hex. We add a header to that thing. We add a domain to the end of that. And then we cause a DNS lookup to occur. Okay, so it's, the process is, it's not that complex. But the interesting thing with that is it's all done in that long piece of T-SQL. Hence, you need an injection point of about 600 bytes. And then finally, once those DNS requests are initiated and they come back to our DNS server, we've got Squeezer, which is capturing that stuff, decoding and storing. And the reliability is simple. If at the end of this process they're missing blocks, we simply re-request them. Okay, the second slide on Squeezer's internals basically is a couple of things to consider. The first is that the way that we get data into tables is not related to the way that we get data out of tables. So we can mix and match modes. We can say putting data in will come from a SQL query, or we'll put data into the table from a command execution. And the way we're going to get it out is, that can also vary. So in this case, we're going to look at DNS. Just now, we'll also look at timing. And that's how this ties in quite nicely with the presentation. So by default, when we want to initiate those DNS requests in SQL Server, the standard method would be xbcmd shell plus ns lookup. But as has already been pointed out, often you'll find that xbcmd shell is disabled or the user doesn't have rights to it because you're not connecting as a sysadmin. And the question then arises, can we initiate DNS requests in a SQL Server without using xbcmd shell and ns lookup? And if I'm posing that rhetorical question, the answer is, of course. There's a stored proc called getFileDetails. There's also an extended stored proc. And that particular stored procedure will take a path name and try to get some file information from it. Now, that's interesting to us because it doesn't require a level of privilege at all. All you need are execute permissions in the database. It's available to the public. So that makes at least two different channels. If we look up DNS through NS lookup, we can specify more data. GetFileDetails as a stored proc has got a limitation of about 128 bytes. And the reason for that is because it uses UNC parts. So the first graphic there shows that actually it is available to everyone. And the graphic below that shows a typical GetFileDetails request that we would make. So basically that's a block that's been hex encoded. At the front it's got a header, and we pass that UNC path into GetFileDetails. And what that does is it then initiates DNS requests, which we capture with Squeezer. So what I'll do now is I'll give you a very brief demo of Squeezer in its DNS mode. This will give you an idea of the network setup that we've got. Basically, there's an attacker. He's connecting to a web server, which passes requests to a database server. We don't have outbound TCP, only inbound TCP. But what we do have are a chain of DNS servers, so the requests will get back to us. Okay, so with Squeezer, what we've got, first of all, is a very simple config file that basically specifies what the target is